Okay, so for this video, we will be going over some examples of solving systems of linear equations with three equations and three variables. Pause the video, write this example down, and I want you to pause and think. Look at all the coefficients of x and y and z, and think to yourself which variable would be the easiest to eliminate. So if you look at the coefficients of x, we have a 3, a 4, and a negative 2. We can't multiply 3 by a whole number and get 4 to be exactly opposite of 4 or exactly opposite of negative 2. So I'm not going to try x unless I have to, and then in that case it's fine. It's just a little bit more work. And if you look at the y coefficients, it's negative 3, and negative 2. The negative 3's would work out easily. We could get those to eliminate pretty quickly, but then we have that negative 2y in equation 3, which I'd have to multiply by a fraction again, or multiply both equations by something. So I'm not going to do y, but if you look at z, you get a negative 4, a positive 1, remember there's really a 1 here, and a negative 2. I can eliminate z probably most easily. So let's do that. So if I pick equation 1 and 2, in equation 1, the coefficient of z is negative 4, so I want the coefficient of equation 2 to be a positive 4. So I'm going to multiply every term in equation 2 by 4, and I'm just going to rewrite equation 1 right here. 3x minus 3y minus 4z equals negative 2, and then multiply equation 2 by 4. 4 times 4 is 16, negative 3 times 4 is negative 12, and then plus 4z, which is what I want because I want the z's to be exactly opposite, and then 1 times 4 is 4. So I'm going to add down right now, and I get 19x, negative 3y minus 12y, or plus a negative 12y is minus 15y, negative 4z plus 4z equals 0, which is my whole goal, was to get rid of that z. Negative 2 plus 4 is 2. I'm going to call this equation 4. Put a circle around it, keep track that that's our fourth equation. Now I'm going to eliminate z again, so you got to pick equation, we have to use equation 3, and then pick 1 or 2 to eliminate the z, and I'm going to use, if I use equation 2 again, I have a 1z and a negative 2z. All I need to do is multiply equation 2 by 2 this time, and then the z's will drop out. So I'm going to put equation 2, and I'm going to multiply that by 2. So every term has to get multiplied by 2. So that's 8x minus 6y equals 2, not equals, plus 2z equals 1 times 2 is 2. And then we're just going to rewrite equation 3 right underneath it. We get negative 2x minus 2y minus 2z equals negative 3. Put a bar through that z so you do not confuse it with a 2. It's so easy to do that. Okay, so 8x and negative 2x, this is 6x. I'm just adding straight down. Negative 6, watch your negatives. And negative 2 adds to negative 8y. The z's dropped out, which is my whole goal. And then I have 2 and negative 3, which adds to negative 1. I'm going to call that equation 5. Now I have, if you look at your coefficients of 4 and 5, they're a little crazy. Nothing is going to work out perfectly, it's not going to be real simple to make x or y exactly the opposite. So we're going to need to multiply both equations by something to get them to be exactly the opposite. So I'm going to do, I'm going to get rid of y, and either variable will be just fine, but I don't know the least common multiple of 15 and 8. So what I'm going to do is I'm just going to multiply this top equation by 8, and I'm going to multiply the bottom equation by negative 15, and then 8 times, for the equation 4, 8 times the negative 15 is 120, and then negative 8 times negative 15 is positive 120. My y's will end up dropping out because they're going to be exactly the opposite. So I'm going to grab a calculator. 19 times 8 is 152x, and then minus, just double check this, negative 15 times 8 is that's going to be minus 120y, and then 2 times 8 is 16. And then down here, 6 times 15 is 90, but it's a negative because I have a positive times a negative. And then this is plus, because I have a negative times a negative. 8 times negative 15, y, and then negative 1 times negative 15 is positive 15. Okay, so 152 minus 90, when I combine those coefficients, I get 62x. My y's drop out, and this is equal to 31. To solve for x, I need to divide by 62, and oh, that's nice. It comes out to be 31 divided by 62 is 1/2 if you simplify that. So I get x is 1/2. Now I'm going to put that value of x back into equation 4 or 5, either one. I'm going to pick equation 5, just because 8 is smaller than, it's easy to take half of 6. It's easier to take half of 6 if I put in a half here than it is to take half of 19. So I'm picking equation 5, and I'm going to plug this in for x. So I have 6 times 1/2, or half of 6, which is going to be 3, minus 8y equals negative 1. And then you go ahead and solve that for y. Half of 6 is 3, minus 8y equals negative 1. Subtract 3 from both sides. You get, don't forget your negatives, negative 8y equals negative 4 on this side. Divide by negative 8. Divide by negative 8. And I get y equals negative divided by negative is positive, and 4 divided by 8 is 1/2 again. So my y value is also 1/2. And now I need to throw that back into the x value and the y value back into equation 1, 2, or 3 and find z. Why don't you pause the video and pick one of those equations and solve for z. And then come back to see if we got the same thing. All right, so I have x is 1/2, y is 1/2. I'm going to throw that into, I'm going to pick equation 1. So we're going to be solving for z. Solve for z. So 3. Oh, nope. I decided I'm going to pick equation 3. And the reason is because the coefficients are all even numbers, and if I take half of an even number, it's going to be easier than taking half of an odd number. So I'm going to go negative 2 times 1/2. Half of negative 2 is going to be negative 1. Minus 2 times 1/2. Again, that's going to be minus 1. Minus 2z equals negative 3. So negative 2, half of negative 2 is negative 1. Minus 1 again, minus 2z equals negative 3. Negative 1 and negative 1 is negative 2 minus 2z. Notice that all the terms are negative. I could just wipe out all those negatives by multiplying every term by a negative 1, but I won't do that. So I add 2 to both sides, and I'm going to get, this is going to disappear, so I end up with negative 2z equals negative 3 plus 2 is negative 1, and then divide by negative 2, divide by negative 2. Again, z is also 1/2. So, and you should go ahead and check the solution, but to write out the solution, what we want to do is write it as an ordered triplet, and it has to be x, y, z. So our solution to this system, barring any mistakes, but again, check it, put it back into each equation. You can throw it into a calculator if you want to. 1/2, 1/2, and 1/2. All right. So it is an independent system and has one solution because we came up with one ordered triplet. Okay, for this example, let's decide if the system is inconsistent, dependent, or has one solution. So go ahead and pick one of the equations. I'm going to try to eliminate y, and I want you to do that in equations 1 and 2. So you're going to multiply equation 1 by 2, because then this will become an 8, positive 8 right here, and then the second equation has a -8, and the y will drop out. And we can also add equations 1 and 3 to eliminate y. So go ahead and do that while the video is paused, or pause the video, yeah. Okay, so when I combined equation 1, multiplied it by 2, and then added it to equation 2, all of my variables dropped out, and I get a false statement. So going back to the first video, what does that mean? That means that we have an inconsistent system. When you come up, all the variables drop out, and you come up with a false statement like this: 0 is never equal to -2. That means that the system was inconsistent. So you can stop right there, because we're not going to be able to find a solution. So I want to do this type of solution as well when you don't have all of the variables. So first of all, I'm going to rewrite this so that the x's line up, the y's line up, and the z's line up. All right, so that's how you would rewrite it. And now we have our x's lined up, our y's lined up, and our z's lined up. Notice all of the coefficients are 1 or -1. This is actually going to be a little almost easier, even though it looks challenging. But let's look at eliminating z between these two equations 2 and 3, because they're already opposite. So I'm just going to do it right here. So I have an x plus, there's no x up there, but adding 0 plus x, you get x. And then I have plus, this is a positive y. The z's are gone, and I end up with x plus y equals -3. And then if I look at equation 1, I'm going to call this equation 4. Look at equation 1, it's exactly the same. So when I add these guys together, I get, oh, wait, it's exactly the same. So what I'm going to do is I'm going to multiply this one by a -1 so that I have, my x's will drop out because they'll be exactly opposite. So I'm going to just rewrite this one. And then multiplying by a -1 changes the sign on everything here. Add down, and you get 0 plus 0 equals 0. Now all the variables dropped out, and I have a true statement because 0 is equal to 0. And so therefore, you're going to have a system that is dependent, and it's going to have an infinite number of solutions. So when all those variables disappear, don't think you did it wrong. It's one of those scenarios from the first video where they either, there's like an infinite number of solutions because they all intersect in a line rather than just a single point, or it's the same plane. And so that is a dependent system. So that would be your answer for that type of problem. And you'll have some with fractions, but you can just clear the fractions if you want to. Like for this problem, I can multiply everything by 2, and I will not have any more fractions multiplying by 2. If I multiply every single thing here by 2, I get 4 times 2, which is 8x, and then plus 6y, and then 3/2. And I'm going to leave a space for the z. 3/2 times 2. The 2's are going to cross out, and so I end up with just 3 over here. If I multiply this by 2 and this by 2, I will also have cleared the fractions. You do that. Okay, so this is what you should have gotten. And now I'm going to eliminate, I'm going to eliminate z. So I'm going to take this third equation and I'm going to multiply it by 2 so that the z's will drop out. So you go ahead and pause the video again and do that. So I had 8x minus 8z equals -1. I just kept equation 2 as it was. And then I get 12x plus 8z equals 6, multiplying the third equation by 2. And then adding down, I get 20x. The z's drop out. 20x equals -1 and 6 is 5. If I divide by 20 on both sides, I get x equals, simplifying that, it's 1/4. So then you can put the 1/4 back into, here, let's do it in equation 1. Oops, I'm going to put 1/4 in here, and 1/4 of 8 is 2. So this is 2 plus 6y equals 3. So we can solve for for y by subtracting 2. I get 3 minus 2 is 1 divided by 6. My y is 1/6. And I have fractions, but they end up working out okay. So now what you want to do is put your x